Welcome back to Prep Forge. Today's topic is a favorite in system design interviews for microservices, the Saga pattern. Here's the problem it solves, in one sentence. When a single business action, like placing an order, spans several microservices, each with its own database, how do you keep everything consistent when one step fails halfway through? You can no longer wrap it all in one database transaction. The Saga pattern is the answer. In this video we'll build it up with one simple example, ordering a laptop online, and cover the happy path, compensating transactions, the two ways to coordinate a Saga, the real challenges, and when to use it. Even if this is all new to you, by the end it will click. Let's get started. Let's set the scene. In a traditional monolith, placing an order is easy. One application, one database, one transaction. You reserve stock, charge the card, and create the shipment, and if anything fails, the database rolls the whole thing back automatically. That's the ACID guarantee. Now we move to microservices. Orders, payments, inventory, and shipping are each a separate service with its own database. There is no shared transaction across them. So if you reserve stock and charge the card, but shipping fails, you can't just roll everything back with one command. The stock is reserved, the money is taken, and there's no automatic undo. That's the distributed transaction problem. And the classic textbook fix, two-phase commit, is slow, and locks resources across services, so it doesn't scale. We need something better. Concept 1: What a Saga actually is. The core idea is beautifully simple. A Saga breaks one big distributed transaction into a sequence of small, local transactions, one per service. Each local transaction updates its own database and then triggers the next step. Here's the key part. For every step that changes data, you also define a compensating transaction, an action that undoes it. So if step 4 fails, you run the compensating actions for steps 3, 2, and 1 in reverse, to walk the system back to a consistent state. A Saga doesn't give you instant, all or nothing consistency. It gives you eventual consistency. The system becomes consistent after all the steps, or all the compensations, have run. Concept 2: Let's walk the happy path with a real example, ordering a laptop. You click Buy on a laptop. Step 1: The order service creates the order in a pending state. Step 2: The inventory service reserves one laptop from stock. Step 3: The payment service charges your card. Step 4: The shipping service schedules delivery. Each step is a local transaction in its own service, and each one, on success, triggers the next. When the last step finishes, the order service marks the order confirmed. For services, for local transactions, chained together. When everything works, that's all a Saga is, a relay race where each runner hands off to the next. Concept 3: The interesting part: What happens when a step fails? Now suppose the first 3 steps succeed: order created, stock reserved, card charged, but step 4, shipping, fails. Maybe your address is outside the delivery zone. We can't leave the system like this. Your money is gone and stock is held. So the Saga runs the compensating transactions in reverse order. First it refunds your payment, undoing step 3. Then it releases the reserved laptop back to stock, undoing step 2. Finally it cancels the order, undoing step 1. Each undo is itself a local transaction. Notice these are not database rollbacks, they are new actions that semantically reverse the previous ones. A refund isn't uncharging, it's a new payment in the opposite direction. That distinction is exactly what interviewers want to hear. Concept 4: The first of 2 ways to coordinate a Saga, choreography. In a choreographed Saga, there is no central boss. Each service simply listens for events and reacts by publishing its own. The order service creates the order and publishes an order-created event. The inventory service hears that, reserves stock, and publishes a stock-reserved event. Payment hears that and charges the card, and so on down the line. If a step fails, it publishes a failed event, and the previous services listen for it and run their compensations. It's fully decentralized. The upside is loose coupling and no single point of control. The downside, the workflow is scattered across many services, so it's hard to see the whole picture, and easy to create confusing cycles of events. Concept 5, the second approach, orchestration. In an orchestrated saga, one component, the orchestrator, is in charge. It acts like a conductor. It tells the order service, create the order. When that succeeds, it tells inventory, reserve stock. Then it tells payment, charge the card, and so on. The orchestrator holds the workflow logic and the current state of the saga. If a step fails, the orchestrator is the one that issues the compensating commands in reverse. The upside, the entire workflow lives in one place, so it's easy to understand, test, and monitor. The downside, that orchestrator is extra infrastructure, and you must be careful it doesn't become a bottleneck or a single point of failure. Concept 6, which one should you pick? This is a very common follow-up question. Here's the trade-off in one breath. Choreography is event-driven and decentralized. It shines for simple sagas with a few steps, keeps services loosely coupled, but becomes hard to follow as the workflow grows. Orchestration is centralized and command-driven. It shines for complex sagas with many steps and branching logic, because the whole flow is visible in one orchestrator, at the cost of extra infrastructure. The rule of thumb, reach for choreography when the workflow is short and simple, and orchestration when it's long, complex, or you need clear visibility and control. Concept 7, the hard parts. Mention these and you'll stand out. Sagas come with real challenges. First, no isolation. Unlike a database transaction, other users can see the intermediate state, for example, an order that's created but not yet paid. This can cause dirty reads, and you handle it with techniques like semantic locks, marking a record as pending. Second, every step and every compensation must be idempotent, because messages get retried, and running the same step twice must not double charge a customer. Third, compensations can themselves fail, so you need retries and, ultimately, a way to alert a human. And fourth, observability. Because the transaction is spread across services, you need good tracing to follow a single saga end to end. These are the details that separate a textbook answer from real experience. Concept 8, what an orchestrated saga looks like in code. With an orchestrator, you define the saga as a list of steps, and each step has two functions, an action and its compensation. For example, reserve inventory, with the compensation release inventory. Charge payment, with the compensation refund payment. The orchestrator runs the actions in order. If any action throws, it stops and runs the compensations for all the completed steps, in reverse. Frameworks like Camunda, Temporal, or Axon do the heavy lifting, persisting the saga state so it survives a crash and resumes correctly. But the shape is always this: forward actions, paired with backward compensations. Concept 9, when the saga pattern is the right tool, and when it isn't. Use a saga when a business process spans multiple services or databases, and you need consistency without locking everything with two-phase commit. It's the standard answer for long-lived, distributed workflows in microservices. Do not reach for it when a single service and a single database can do the job. That's just a normal ACID transaction, no saga needed. And avoid it when you truly need strict, immediate consistency and cannot tolerate any intermediate state, though in practice that's rare across services. Said simply, a Saga trades instant consistency for something achievable in a distributed system, eventual consistency, with a clear plan to undo. Explain the laptop order, a happy path and the compensations, and you've shown you truly understand it. And that's the Saga pattern, end to end. A big distributed transaction, broken into local steps, each paired with a compensating action that can undo it. A happy path that chains forward, and compensations that walk backward when something fails. 2 ways to coordinate: choreography with events, or orchestration with a central conductor. Watch out for isolation, idempotency, and observability. Use it for multi-service workflows where 2-phase commit won't do. Explain it with the laptop order and you'll handle any Saga question with confidence. To practice out loud with mock interviews and spaced repetition, head to prepforge.net. If this helped, subscribe for more. Thanks for watching, and good luck in your interview.